Today, thanks to technology, the world is more connected than ever. I'm reporting here at the Pentagon, but you could be watching me from Iran, Brazil, China. The list goes on, all at the touch of a button. And technology has been helping the U.S. military too. It's made it stronger and faster, but it's also opened up some vulnerabilities. Joining me now is the Chief Technology Officer for the Defense Department, Mr. Steve Welby. He's officially known as the Assistant Secretary of Defense for Research and Engineering. Mr. Welby, thank you for joining us.
Thank you, Carl.
Now, in the current age of globalization, data is just everywhere. There's tons of it. So how does the Pentagon manage that?
We're in a world of big data, and analytics are opening new frontiers for the way we handle quantities of data that we could never imagine before. As you mentioned, it's both an opportunity and a challenge. The challenges we see in terms of how we protect ourselves in a connected world against cyber threats and other challenges to our systems. But also it's opening amazing new vistas. We now see that almost everything we're doing in the department is software enabled. There's almost no system today where new capabilities aren't being inserted much faster than ever before, if you will, by downloading apps into our systems. And that's changed the nature of what we do in terms of the way we develop systems. It's changed the nature of our workforce in terms of the increasing software knowledge and proficiency that our people have. And it's changed the way we think about systems in terms of coupling them together, networking them, and protecting them at the same time.
How important is cyber in protecting our Defense Department here in the United States?
We talk about where we need to protect ourselves in the air, land, sea, space, and now in the cyber dimension, this invisible, interconnected space. And it's a critical warfighting domain where we need to make sure that we understand and can defend our systems. We're dependent upon being connected. We're dependent on that flow of data. And today we have very robust tools to help defend ourselves in that space, to ensure that our systems can be trusted, can be relied upon, and will be available when soldiers, sailors, airmen, Marines need them. So it's as critical a space today as any other, and we're trying to ensure that we're invested well in the next generation capabilities that will protect us there.
What's your assessment? Are we invested well, and what do we need more of? I know it's been used in the war against ISIS, Islamic State, for example. Are there improvements that can be made?
Today we've got great tools, and we're fielding more. But I think that increasingly we want to be thinking about how we shift the landscape for the way we protect our systems, the systems that are much more defended, inherently defensible from design. The Internet was built in an era where the goal was sharing data, connecting ourselves more in new ways, without an eye towards how we provide protection. And today we now see the need to balance both that connectivity with protection. And I think that's a great field of research where folks are thinking about new computer designs, new computer architectures, new software techniques that might allow us to prove that systems are in fact defensible, to prove that systems are safe, to be able to ask a computer what it's doing and have it explain to us what it's up to, rather than sitting there chugging away as we all watch that circle turn on our phones. That idea of having systems that can explain their behavior is an exciting one, and is at the root of an entirely new field of cyber defenses that we're just starting to explore.
So for you, would it be accurate to say that a good defense is better than a good offense?
Well, a good defense is critical, period, and to everything we do.
Now, you have clearly been a science guy your entire life. I was reading a little bit about your background, a science degree in chemical engineering from the Cooper Union, master's degrees in computer science, applied mathematics from the Johns Hopkins University. How did you end up here at the Pentagon?
I've had a remarkable career, and I've been incredibly lucky to be involved on the cutting edge of really interesting things my entire career in the department. I began my career with the Army Research Laboratory, where I worked early on technologies that became part of the ground stations for our unmanned aircraft that we're flying today. I was at the very birth of some of those technologies on Predator, and then found myself at Defense Advanced Research Projects Agency at DARPA at the time that systems like Global Hawk, our long-endurance unmanned air system, were being born. And thinking about an aircraft that could stay up for 40 hours at a time and sweeping up enormous quantities of information, and how we could think about processing that in real time was really part of the motivation behind core technologies that have led to much of the revolution today in big data analytics. I've had an opportunity to live in the future for a long time. At DARPA, I had a chance to work on, as I mentioned, unmanned air vehicles, on directed energy systems that have brought enormous improvements in laser performance. The DARPA Grand Challenge that we ran, trying to get a vehicle to drive across the desert from Los Angeles to Las Vegas, which gave birth to now an entire industry in autonomous vehicles. I was out in Mountain View, California a few weeks ago, stuck behind one of those Google unmanned cars, doing exactly the speed limit and wondering, how did I get myself here? Why was I involved in these projects early on? Now I'm stuck behind them in traffic. But we've seen technologies developed in the department in GPS, the internet we talked about earlier, unmanned systems now emerging from the work of scientists that I've worked with, and now helping to shape entire industries and new commercial sectors. And I think that's been remarkably exciting.
Which one of all the programs that you've championed are you most proud of, and which one do you think is the most successful? Would that be the drones?
I do think that thinking about unmanned systems and autonomy has been enormously important. I look at the coming explosion in robotic systems in the commercial sector. I see the way that autonomous systems are moved from the laboratory into application, self-parking cars, adaptive cruise control, things you can order on a vehicle today. Were dreams in the minds of scientists just a few years ago. And seeing that technology move quickly out of the laboratory through military applications and now into the commercial sector has been very exciting. I think since, if one looks back at technology since the 1980s on, the shift in U.S. investment in military technology, the emergence of precision weapons capabilities, of network systems, of advanced targeting capability, of unmanned systems, have fundamentally changed the way we fight. And I think it's dramatically reduced collateral damage in the way these things are. There are always unfortunate things that happen in warfare, but I think that combination of expectations that have been raised by having real-time situational awareness, to have eyes on, to be able to bring effects to bear at exactly the spot on the planet Earth that you want them to occur, is dramatically different than kind of the history of warfare. And I don't think we often get credit for that efficiency and improvement in terms of the way that we protect those that are unfortunately in the area when these things happen. So I think that there's been a fundamental revolution in those technologies, and I think that on the whole, I think history is going to evaluate them positively, actually, in terms of avoidance.
Now, coming up in a couple months is the Cyber Grand Challenge, which has been described as the first all-machine hacking tournament. Can you tell us a little bit more about this and what they're trying to do and how that can be applicable to real-life scenarios?
DARPA has been working, we talked about challenges in cyber earlier, thinking about how we can start to protect systems at cyber speed. And one of the things that hackers, folks who are trying to penetrate systems do, are they play these games of capture the flag. Folks post a system up and folks come by and they try and break into the system to see who's got the best skills to be able to break into a system. And other hackers will defend the system. And it's actually an interesting game that people play out at some of these major cyber events as folks conduct these competitions to see who's the better defender, who's the better attacker, who can actually beat each other. Later this summer, out in Las Vegas, DARPA will be sponsoring this game without human players. It'll be computers trying to break into systems and computers trying to defend systems. And it'll be a machine-on-machine sort of game to understand what the state-of-the-art is in the ability to provide automation and to apply artificial intelligence techniques that operate at machine speed to protect systems in new ways. I think it's going to be really interesting to watch these machines compete one against each other at amazing speeds, using the software that was built by the teams that are employed doing this. It's really the art and talents of those individuals expressed through the machines taking each other on in real time. It's going to be an interesting competition, and it's also an interesting challenge to the technology, and I'm very excited to see how that plays out. But it's really going to be getting them smart and then letting them go and seeing how they fend for themselves. We've had great success in the department using concepts like this, prize competitions, to spur innovation. By putting a small pot of incentive on the table and providing a venue for people to bring things to bear. I mentioned autonomous vehicles earlier. Much of the breakthrough work in that field was not done by folks that were funded by the department to do a specific project, but was funded by groups that raised money themselves to participate in a challenge the department put out in front of them. And I think that's a very exciting and new opportunity for us to think about ways to incentivize technology development. And the Cyber Grand Challenge is going to be another great place for that to play out.
There's some biotechnology. There's a camouflage that's inspired by a squid, I've heard. Can you tell us a little bit about that?
So for so long, biology has been kind of a descriptive science, right, where folks have studied the world and try to understand how it works. Today, we're starting to manipulate biology in interesting ways, and it's inspiring work in new materials and new systems concepts. The bio-inspired camouflage work that's going on out at the Air Force Research Laboratory is really interesting. They're looking at cephalopods, these sea creatures that just do amazing things. There's great videos on the web of just unbelievable ways that these not all that attractive creatures blend into their environment and are able to adapt in just amazing speeds. They'll glide over a piece of rock or a piece of coral and just disappear as they adapt to that. And studying those creatures, we've identified really novel proteins that are in the skins of those animals. They're called reflectins, and they're small proteins that are able to change shape and change their reflectivity very quickly. And we're now thinking about how one could build materials using basically those same proteins, learning from those squids, if you will, to think about how we might be able to adapt those into small films we might be able to use to treat vehicles that we don't want folks to discover, to allow us to control reflectivity, perhaps to be able to control thermal management on systems. And so like a large number of programs in the department, we're now learning from nature and applying it in new ways.
Now, how far along are you on that research?
We've folks have been looking at this for some time. I think there are now some interesting prototypes that folks are playing with, and I invite you out to go visit the folks at AFRL. I'm sure they've got some interesting materials you could look at.
We will definitely go and take a look at that. I wanted to also talk about electrics. That was targeting parts of the nervous system to try to self-heal. Can you talk about that? That sounds like an amazing breakthrough.
Yeah, so Electrics is a DARPA program, and it's really asking folks to help heal themselves, and I think that's a novel way to think about therapeutics. If you think about the way the human body self-regulates, we have sensory nerves embedded throughout your body, and they're monitoring your health in real time. They provide feedback to your brain and to your spinal cord. And just reflexively, your body is controlling the reaction of its organs to help maintain homeostasis, to make sure that your body is healthy and balanced. When disease occurs, your body can lose its ability to self-regulate. Kind of three places you see that. One is, of course, in chronic pain, where the system isn't able to self-regulate, and you have this continuous pain mechanism, which is debilitating to the individual. You see it in autoimmune diseases like rheumatoid arthritis, where the autoimmune system is not able to correct and the body tends to attack itself. And you can see it in metabolic disorders like some forms of diabetes, right, where your body loses the ability to properly regulate insulin, do that feedback. And the notion is today, can we start to think about using electronics to provide a little bit of a kickstart to the body to help our own regulatory system, our own feedback loops, to provide additional feedback into the nervous system when it's not entirely operating properly, to provide a backup monitor, if you will, to the body's own regulator system, and by providing small electrical impulses right back into that nervous system at just the right points in time to amplify the signals that the body needs to kind of keep itself in check. There's great opportunities here to think about new drug-free methods to allow the body to protect itself in ways that we just haven't been able to do before. And breakthroughs in electronics, new ways to couple electronics right back into the human nervous system are opening an entirely new frontier in medical technology.
And this is science that's being done right here in the Department of Defense, but can be applied not just to servicemen and women, but to everyone.
I think that's an important thing to note. The department funds an enormous amount of basic research, and that all grows from our laboratories, from our engagement with universities, from our engagement with companies. It's not all about building the next military combat vehicle. It's about how we think about caring for our soldiers, sailors, airmen, and Marines. It's how we think about increasing their effectiveness on the battlefield. It's how we think about how those technologies might couple into the commercial sector and help enable new opportunities in the commercial markets as well. And I think the medical areas are great examples of where the work we're doing to support our military folks have immediate and kind of direct consequence in the commercial sector.
What else are you working on in the medical field that's really sticking out to you as one of the most exciting things going forward?
Yeah, so I think an area where we're very actively engaged is in supporting the President's BRAIN Initiative, the White House BRAIN Initiative, which is looking at the technologies to map the human mind and to be able to engage it in new ways. One of the real challenges we have in the department is the problem of traumatic brain injury. Folks who are exposed to shocks on the battlefield and suffer brain challenges because of that. And that often exposes itself in loss of memory function. Folks can often form kind of those emotional connections around events, but they lose the details, the facts. And you can see that in other degenerative brain problems. This impacts over a 250,000 U.S. servicemen and women since 2001, and is a much larger problem in the larger ecosystem. There's over 1.5 million folks across the U.S. who are affected by these kind of memory disorders every year. We're now looking at ways to think about and image, understand the way the brain forms these kind of memories, to capture the processes that allow us to retrieve facts from memory, and to understand how physical damage maps into damage to the pathways that allow us to encode and recover memory. We think that that'll help us discover new ways to provide, again, that kind of feedback and aid, perhaps systems that one might be able to wear that might be able to help restore function on parts of damaged brains. And it's an entirely new field. Areas that we just didn't think were possible before. We're now decoding the language of the mind, right? How we actually store facts. I think it's incredibly exciting work to be able to restore these kind of functions to folks. And having had friends and family who've suffered from these kind of problems, I think the hope that offers to folks is enormous. I think we're going to see remarkable breakthroughs over the next 10 or 15 years in that area. And the department's got a lead in some of these areas because it's important to care for our folks. Another area that's important to care for our folks is the enormous physical trauma that folks have suffered. I believe you may have seen some of the revolutionary prosthetics work we had outside here in the courtyard just a few weeks ago.
That's right. The OA was right here.
It was, that to me is just amazing work to see folks who've lost a limb through an accident, being able to put on a device and to be able to have almost all of the natural function of that limb restored through effectively wearing a robotic arm. But controlled very naturally through the severed nerves of the missing limb. I think that's it's just amazing, and it's a kind of thing that was science fiction just a few years ago, and the department has enabled by working with brilliant scientists in academia and within our own laboratories to kind of bring that capability to bear. The next frontier is the work going on in programs like haptics, where we're not just trying to restore the function of those limbs, but actually trying to restore the sensory function as well. And so folks that might be able to lose a limb in an accident to be able to actually restore the sense of touch. It's just an amazing idea that we're now being able to map that kind of two-way feedback into the nervous system, be able to couple sensory devices back into those peripheral nerves in a limb. These are areas of biology that were completely unknown how they worked, how we might be able to engineer around them. And today, there are folks who are now getting restored capability through inventions in this space. So, it's just amazing and exciting stuff.
So when you say that you can restore your sense of touch, are you saying that if somebody were to try to grab an egg, for example, they could feel the point to where that egg was about to break? That
they'd be able to get that kind of tactile sensation, and maybe being able to actually differentiate between roughness of surface, that kind of very fine sensory feedback is not outside the realm of the possible. And just the progress that's been made in just a few short years in that space, from purely conceptual work to now the beginning of prototype devices that folks are experimenting with, is really exciting.
So people are actually wearing this haptics right now and experimenting with it?
That's right. So we through all of our processes, we go through all these ethical reviews and all our internal boards to ensure that first we do no harm and all these kind of things. But we've been engaged with folks who've either through a military service or through an accident in civilian life have lost use of a limb. And many of these folks have been quite happy to join the team and help us understand what the art of the possible might be.
I bet that's got to be a great feeling to be able to make such a difference in somebody's life.
It is amazing to be able to talk to these folks. It's it's inspirational. The work that's going on in our laboratories is really amazing, both in terms of exploring frontiers of science and being able to invent and build things that never existed before, and being able to touch people's lives in these kind of ways. It's really rewarding work.
The military is not all about making people better. It's also about defending and being able to destroy enemies. What are some of the most interesting weapons that you guys are working on right now?
Well, our goal is to be able to deter aggression and ensure that our nation can fight and win if called upon. The goal is not to destroy. In fact, the goal is to minimize destruction to achieve effects. And I think there's really interesting capabilities being developed in areas like hypersonics, where we are thinking about the ability to fly at remarkable speeds, beyond 5 times the speed of sound. As one starts to think about systems that can operate at those kind of speeds, they offer entirely new options for ways to build military systems that traditionally we've thought about trying to be invisible or trying to avoid an enemy. But if you're going fast enough, you can just go past them before they can even know you're there. And it's capabilities like that, I think, that are also really interesting. The enormous challenges in physics and material science, in propulsion technology that have to be solved to get to those kind of platform concepts are just emerging, and I think there's great work going on across the department in those areas. We've been recently talking about concepts like advanced railguns, thinking about systems that are able to take advantage of capabilities to provide that kind of hypervelocity out of a novel gun system. So to be able to think of bullets that can fly many times the speed of a bullet that exists today. That's important because it might allow one to be able to defend oneself against perhaps missiles that are coming at you, to be able to shoot them out of the air. It might allow you to reach out much further and be able to engage a target long before it could engage you. And those kind of capabilities, being able to outreach somebody who threatens you, or to be able to knock a threat out of the air, are exactly those kind of deterrent capabilities that demonstrate to folks it's not worth their time to engage us. We can defend ourselves in those kind of scenarios. And the technologies that allow us to do that, thinking about how we can bring massive quantities of electric power to bear in a very short time to accelerate things to speeds that we've never been able to do before, are really also some of the kind of very cool cutting-edge work that's going on in our laboratories.
Now I want to talk to you about 2 more things real quickly. One of the things is something that VOA has already discussed earlier. It's called Active. It's an unmanned submarine hunter. Can you talk a little bit about that? I know it's in its trial stage right now over in the West Coast. When is that thing going to go active, and what does it do?
I think Active is one of the coolest programs I've seen recently. I was out with the Deputy Secretary of Defense just a couple of weeks ago out in Portland, where the christening occurred for Active. Active is a 180-ton displacement, 170-foot-long ship. It's an experimental craft, and it's different than any other ship that's out there in that there's nobody on board. It's a completely unmanned naval vessel. And it has all the redundancy that allows it to operate at sea without a crew on board. And it has a complete set of sensors, again, redundant and with multiple systems to avoid failure, that allow it to sense other ships on the sea and to behave according to all the laws of the sea, to be able to interoperate with other vessels without causing any harm to anyone. And it's got the kind of range that could allow it to cross an ocean entirely without anybody on board. And it's capabilities like that that allow us to think through, to prototype, to experiment with entirely new concepts. And what could an unmanned ship offer the U.S. Navy that I think are very exciting and compelling. Just as we were working unmanned ground vehicles a few years ago, and so how that's mapped now into the commercial sector. Now we're working on unmanned ships and thinking about how that might influence the future as well. One can think about supply missions. One can think about using it defensively. One can think about using it to hunt mines at sea, to be able to protect seagoing traffic. There's all kinds of missions that an unmanned ship might offer that could take sailors out of dull, dirty, and dangerous missions. And I think this is one of the most exciting things that I've ever actually kind of watched roll out of a dock at scale. The ship has now been moved from Portland. It's now down in San Diego, where for the next year or so, it's going to be conducting sea trials with the U.S. Navy and really exploring how does a manned ship and an unmanned ship work together. What missions could a ship like this help us perform? How could it help change the cost of conducting naval missions to allow us to deploy our ships much more effectively? And what are the challenges? The Navy will work this thing until it breaks, and we'll find out where and how it breaks, and that'll help inform how to build the next one better.
And the last thing I want to ask you about concerning the new technology are the developments with tanks, because I remember starting off in Afghanistan, you used to hear several deaths with IEDs. That has been reduced thanks to some of the technology that the U.S. has developed. So where are we now? How much have we improved over the last decade, and how much are we sharing with our allies, say, in Afghanistan or in Iraq?
The challenge of improvised explosive devices, or IEDs, really drove an enormous spurt of development here at home to try and ensure that we had the right tools in place to help. New forms of armor, new ways to design ground vehicles that allowed crew, in case one of these things went off close to it, to increase their likelihood of surviving. And we've seen enormous reductions in loss of life to these kind of systems. I think that we've been sharing as much of this technology as we can. These are defensive systems that we want our allies and partners to have. There's great international cooperation in understanding these kind of improvised devices, and also in kind of working our way back and preventing those systems from being there in the first place, and ensuring that folks understand where these systems come from, these large explosive devices, and ways to avoid the supply chains that support them getting into the field. Ground vehicles is an area where technology has evolved very slowly. If you go back to look at a tank in World War II and look at a tank today, boy, they look awful familiar from a distance, right? The materials they're made of, the speed at which they travel, the technology within the systems themselves have changed dramatically. But a tank still looks kind of roughly like a tank. And I think as we think about armored vehicles in the future, I think we're now going to start seeing that technology evolve much faster based on lessons learned from the war, based on new materials. I wonder whether 20 years from now a tank will look at all like a tank looks like today, or whether we'll see emergence of new concepts in armored vehicle technology. It's an area the Army is working very quickly. Technology that you see in commercial vehicles, in the cars you see on the road, hybrid electric systems, for example, are going to find their way into tactical vehicles. Lighter weight armors to allow systems to maneuver faster. And I think much better crew-focused protection. Systems that not only allow the vehicle to survive, but are focused on making sure that the young people inside get out and walk away. I think are going to find themselves increasingly incorporated into future vehicles. So I think it's an exciting area as well.
Saving lives is the point. One final thought for you. Several military leaders in this building have said that their goal is to make sure that U.S. service members never go into a fair fight, that they have the advantage in every scenario. Do you see that as your job as well? And do you feel that the United States is going into unfair fights where they have the advantage these days?
Throughout our history, we've been a technologically enabled force. The United States has not found advantage in the sheer number of soldiers we've been able to deploy, but in ensuring that our soldiers, sailor airmen, Marines have always had the best gear, the technical advantage, the best connectivity, the ability to call on each other in a joint fight and win. so much of that is empowered by science and technology. And the tools that we are delivering today are enabled by the scientific and technology advances that have occurred over the last few decades. The work that we're doing today are hoping to ensure that we maintain that advantage into the next few decades.
And are you getting the resources?
I think we're getting great resources. We've got terrific support from this secretary and from the White House, from Congress, in terms of ensuring that we've got the right budget. With all the pressure on the Department of Defense over the last few years, science and technology has been preserved in all the budget cycle we've had, all the pressure on the budget. We've maintained that S&T funding because we see it as a critical seed corn for the future.
Well, Mr. Welby, thank you so much for speaking with VOA today.
I was super happy to chat.
Steve Welby, the Chief Technology Officer for the Department of Defense.